Hey guys, today I'm going to be talking about active versus passive systems, what each one really means, and kind of the hows and whys behind both. We're all musicians. As musicians, we deal in sound and tones, and a lot of us are not very interested to look past the creative stage and learn about what comprises our sound, what comprises our tone, and that's totally cool. And for those of you who have an inclination towards the technical side, this is for you. Okay, so I'm going to enumerate a few basic points here to start out with, and then I'm going to go through each one later and kind of explain better what I mean and talk about each topic separately. All right, number one, all components in a passive network are interactive. They all combine to create your resultant tone. So everything from pickups to the values of the pots that are in your instrument, the degree to which those pots are wide open. So if they're kind of turned back a little bit, you've got less resistance to ground. The cabling that you use, the length of the cable, and an amplifier or audio interface or mixing board's front end, which will have a certain input impedance, all of that combines to create the sound, the resultant sound of your instrument, and it's all interactive in a fully passive system, which is why your instrument might sound different in one scenario versus another. Okay, more about that later. Point two, active systems were designed basically to solve a lot of the common problems that musicians have. So there was a purpose for them. Point three, all amplified or recorded signals are active, flat out. Your passive instrument isn't really passive, at least not when you hear it. The only way to hear a really passive, a truly passive signal chain is from an acoustic instrument that's not amplified. Whether it happens at the amplifier, after the input stage, but at the amplifier, or at an audio interface as you're recording, or at a mixing board, anything that you then hear through speakers or headphones or experience in any other way but being there in the room with a cord not plugged in is an active signal. Active signals require power and usually involve amplification. They're boosting things. So everything's active at a certain point. The difference is where in that signal chain it becomes active. Does it become active at the output jack or at the last part of your chain, or at a pedal that you have in the middle of it that you always keep on? More about that in a moment. Okay, and the last point is that for guitar or bass scenarios, there are four main versions of active or passive situations that you can have on board. This is on board only. So you can either be what I'll call passive-passive, which is passive pickups with a passive circuit. Both sections of that, the pickups and the circuit, are passive. Then there's active-passive. So active pickups, the pickups themselves are active. This is another poorly understood thing. A lot of people think being active means that the pickups themselves are active, and in the modern world, in the modern kind of state of things for bass players especially, that's not usually the case. But more on that in a minute. So active-passive, active pickups, and a passive tone circuit. All right, and then we have active-active. That is where you have active pickups running through an active preamp. Both items require power to function. And finally, we've got passive-active, which is passive pickups run through an active tone control circuit. So this last one is kind of the majority of what you see on the market today in terms of active instruments. They're really passive pickups run through an active tone control module that requires power, and you may or may not have the ability to bypass that active part of the circuit. Okay, more on point number one. So all components in a passive network, as I was talking about, are going to influence the way your instrument sounds. This is because there is no electronic circuitry buffering or separating, kind of holding back one part of the signal chain or one part of the circuit from another. So your pickups have a certain DC resistance. They have a certain resonant peak. That stuff is kind of, I'll not go into too much detail there, but Those influence how bright or how dark the pickups sound, a lot of other characteristics as well. But those characteristics are altered based on what you plug into. They're altered, first of all, based on your volume and tone pots, if you have them, and where they're set, how much resistance there is to ground, how much inductance there is in the circuit, and then you have capacitance, which is a tendency of signal to diminish over time, and it diminishes over distance of cable, and it diminishes from the high frequencies first. So that means you take a passive instrument, you plug it into an amplifier with a 100-foot cord, it's going to sound darker at the end of that 100-foot cord at the amplifier than the same instrument would sound with a 15-foot cord. That's due to capacitance. You lose treble frequencies first. And finally, the amplifier input itself, the amplifier input section will have a certain impedance, and that is going to interact, again, with your pickups. So all of these things combine to create the final sound that you hear. The difficulty in a passive network, then, there's an issue with consistency. Based on what you plug into, based on how your controls are set, how long the cable is, all that stuff I talked about, you're going to end up with a slightly different tone. It's not going to be the difference of switching from one instrument to another, but it may not be what you expect to hear, what you want to hear. So that brings me to point 2, which is that active systems were designed to kind of deal with some of the problems that electric and electronic instrumentalists have had. One of those is the fact that if we take guitars and basses, passive pickups put out what's called a high impedance signal. And not going into too many specifics here, but basically high impedance signals they're not ideal for interfacing with most other pieces of audio equipment or pro audio equipment. They're great for interfacing with amps because amps are meant to take that signal. But this is one of the reasons why you might want to use a DI before you go into a front of house mixing board or into an audio interface or something like that. There's a lot of benefits from taking that high impedance signal and making it low impedance. What are those benefits? Well, one of them is that your signal is now much less susceptible to capacitance. And again, that was that tendency of high frequencies to diminish over lengths of cable. So a high impedance output signal can be kind of problematic. It will be transformed into an active signal at some point in the chain. One of the other issues with passive networks is that consistency item that I brought up before. So one of the things that's great about buffered circuits, that's another way of talking about an active circuit, basically where a signal is conditioned, it requires power, requires electricity, usually through a battery, but there have been systems like the Alembic system where you have phantom power or something like that that's providing the power. Buffered systems separate components from each other, and one of the things that they do is separate components from each other and prevent them from cross-talking to a great degree. So it kind of freezes your output tone in place at a certain point. So if you have buffers right after the pickups, it doesn't really change anything that's inherent or innate about the pickups. It basically, depending on where the input impedance of the buffer is set, it freezes your pickup's resonant peak. It freezes how bright they are, how dark they are at a specific point, so that an amplifier down the road or a pedal or whatever else you're plugging into won't have an effect on changing your tone. You can kind of rest assured knowing that you're going to sound a certain way in most different contexts. On top of that, you can add in things like gain boosting, which allows you to raise the level of weak pickup signals, and of course EQ variation. So you can boost different parts of the audio spectrum, which is and cut also, which is something that active EQ allows you to do. Passive systems, by definition, can only be subtractive. They can only take things away. You can't ever add anything in that wasn't there to a passive system. So active introduces buffering of components. So it's kind of just like saying this is what this instrument is going to sound like at its output, regardless of what I plug into after that. And then whatever you do plug into can do additional tone shaping, but it's not going to interface directly with the pickups unless you have an active-passive bypass. Okay, so now we're talking about the 4 different basic scenarios of the mixture, or not mixture at all, of passiveness, passivity with activeness in electronics. So passive pickups, which is the vast majority of pickups, and a passive circuit, which might include a capacitor that's going to ground in parallel with your output. That's what a tone control is. So as you roll it off, it's sending more of your signal in parallel to ground. That makes it darker. A lot of electronic interaction happening there. That's why that happens. You're interacting with the pickups, you're interacting with the cable, you're interacting with the pots themselves, and with whatever you're plugged into. Next is active pickups, active-passive. So active pickups with a passive tone circuit. So you might see this, say, in a guitar equipped with EMG pickups, but no preamp. EMG systems, there are active EMG tone circuits, like the VLPF that EMG makes, it is active, it requires power. But you can technically, you could just run active pickups through a passive tone control and passive volume control. You just have to have the right values for those. Then we have active. So these, a good example of that would be a lot of Warwick and Spectre basses, for example. The Warwick basses that use MEC pickups, or Spectres that use EMGs, both models being the active variants, because both of those brands have versions of their pickups that are passive. But if you have an active pickup like that and you're running it through a preamp on board, that would be active. So in that case, you can actually say active pickups. You're actually dealing with active pickups, as we were in just the previous case too. So the pickups actually require power to function, and then the preamp itself requires power to function. There is a preamp. There is an electronic circuit there that requires power. Active pickups, this is probably kind of beyond the purview of this video, but active pickups themselves allow you to do a few different interesting things. I'll just to name a couple real quick. If you have a humbucking pickup in a passive component, in a passive system, a signal from 2 different coils has to be combined, and the coils have to be reverse wound and the opposite polarity. They have to be combined either in series or parallel to function as a humbucker and to have a single unified output. Active systems don't necessarily work that way if they're built into the pickup themselves, because you can put each coil through its own channel on an op amp, so they're electrically isolated now, they're buffered from each other, and then they get summed. So it's actually not the same as connecting 2 coils passively, because when you connect 2 coils passively, you change things like the inductance of the pickups, and you change resonant peak, you change a bunch of different things because they're interacting, they're loading each other. And again, passive is all about interaction. So the coils are interacting with each other and changing the way that they sound. Neither one is superior, they just sound different. So that's one kind of interesting item on active pickups. Another thing that you can do is use pickup scenarios, pickup coil architectures that don't work so well in the passive world, or have a really low output, like a stacked humbucker. So if we look at an EMG jazz style pickup, or an MEC jazz style pickup, it's a humbucking pickup that's really, it's a humbucker. There's 2 coils. Only one is sensing, there's one on top that's sensing the strings, and then there's a dummy coil on the bottom. What that does in a typical passive scenario is, well, it hum cancels for sure, but it makes for a kind of weak output that's not particularly very exciting sounding. But one of the things that an active architecture in that sense allows for is keeping the humbucking quality and then raising the output level, again through an amplifier, through this little op amp, through an amplifying chip. You can raise the output level and if necessary, apply some basic EQ to the signal there in the pickup to tune it to how the manufacturer wants it to sound. And you can do that in each pickup. So you can use that stacked coil architecture that doesn't really work out so well oftentimes in the passive world. And you can use it effectively, so it has the same output volume as a typical pickup. Those are just a couple scenarios for active pickups. All right, so let's get to the last one, which is going to be a majority of people here. Passive pickups with an active circuit. So in the bass world, that's kind of that's been kind of the flavor of the month for many months. It's kind of been the way that things are for a long time if you have an active circuit. As I said before, the vast majority of pickups themselves that are produced are passive. They're a very simple little machine. They're a coil of wire around a magnet or magnets, and sometimes there's more than one coil of wire, and that's it. That's basically how a pickup works. So the strings vibrate, the strings have to have ferrous content, they have to have iron in them. That disturbs a magnetic field. That magnetic field induces a voltage in the coil of wire, and that voltage is a AC signal, like electricity. It literally comes out a very small voltage that needs to be amplified through an active part of the circuit in order to hear. That's your amplifier typically. So most pickups are in fact passive. So in a passive-active scenario, you've got passive pickups which are being run through an active preamp. There are so many different flavors of active preamps, it's almost impossible to know where to start. Some use buffering systems. I play MTD basses. These use a buffer, in fact a stereo buffer, so a separate buffer for each pickup signal in a 2-pickup bass, to isolate the pickups from each other before going on to the rest of the preamp. And that allows you to do what's called a buffered blend or an active blend, where your blend knob really becomes more like kind of a fader on a mixing desk. It really actually works from one side to another side. That's one benefit of doing things that way. But again, there's nothing really superior or inferior about any of the ways you can do this stuff. They just give you different results. But the active circuit itself on board will buffer and transform your output signal into a low impedance signal. And that's kind of the main deal here. When you send a low impedance signal out from your instrument, it's kind of more robust in a lot of ways. It's less susceptible to noise, it's less susceptible to capacitance. It is more conditioned to be plugged into a mixing desk or an audio interface, something of that nature. Oftentimes, of course, we still go through DIs, but you can now run through long lengths of cable, and the main thing is, while that active circuit is engaged, if you can bypass it, not all of them are bypassable, but while that circuit is engaged, your instrument's going to pretty much sound like your instrument regardless of what amp you plug into or what pedal you plug into. You're not going to get that same level of interaction between the individual pickup coils and all of their little quirks. You know, their resonant peak, as I mentioned before, which determines at what point the treble starts to take a nosedive, so how bright they are, in other words. All those little quirks in a passive system, that's part of what people like oftentimes in passive systems when they're hearing that stuff. Again, the preamp, the buffered part, freezes the sound at a specific point. So it's up to you to basically decide whether that is worthwhile to you or not. Personally, I think that's a big plus. For me, there's a lot of power involved in knowing that the output of my instrument is going to sound like I am familiar with, like I expect it to sound. And I love having an onboard EQ because I can do a little further tone shaping, and I can be sure of how I'm going to be received in situations where I don't have any control over the reception part. So playing direct, going direct, sending my signal out to a front of house board, recording in somebody else's studio, needing to borrow an amp. all of these things on a passive network will change the sound that you hear from your instrument, at least to some degree, if you don't buffer it at some point. So having the buffered section on board on my basses, having a preamp, allows me to be kind of sure, that I'm going to get something that I'm familiar with, something that I know and like. And then, of course, yeah, just having the ability to tweak EQ to me is beneficial. I tend to do that stuff on board more than on the amplifier. I tend to set most amplifiers flat. Some people never touch active systems on board, or will play with the bass in passive mode if it gives you that option to bypass, and will only change things on a preamp or an amplifier EQ section. Neither one's better than the other, but that's how it works. There's nothing evil or misguided or anything like that about active circuitry. It solves a lot of issues that we've had to struggle with as electric musicians for a long time. It does give a specific kind of sound. It usually ends up giving you kind of more of a brighter sound because it tends to maximize the output of your pickups. It basically doesn't load them down as much, so it lets your pickups just be free and resonate like they want to resonate, and send all of their signal, push all their signal down the path to the next stage. And then, of course, you can use all kinds of EQ, whether it be passive EQ or active EQ, subtractive EQ, or active in that you're boosting things to then further sculpt your tone. But takeaways are everything that you hear, everything that you hear that's not an acoustic guitar or bass that you're in the same room with, it's active at some point. We play electric guitars and basses. The electric part there should tell you it's active. It may be passive at the instrument, but it's active as soon as you step on that distortion pedal. Or it's active as soon as it goes into your amp, and it's buffered there, and then you're boosting the signal, obviously. So there's just a lot of misinformation, and I hope this helps to clear any of this up. I know I just rambled on. This will probably have a lot of edits involved, which is going to be fun for me after this. Hope you like this. Let me know if you have any questions. Leave comments, questions and comments. I'll be happy to try to speak to whatever I can. And yeah, I will see you next time. Thank you for watching.